Alright guys, this last video is on problem solving with quadratics. It's the last particular topic in the quadratic equations topic for year 10 maths. So here again we're applying some of the maths that we've learned into real life situations, and often in real life situations when you convert it to an algebraic form, the situation into a mathematical problem, it becomes a quadratic equation. So until now you haven't been able to solve those. So now you should be able to, but you have to follow the steps below. So it's very similar to problem solving with linear equations. You read the question, sketch it if you can. Always a good idea to visualize the problem. You need to decide on the unknown quantity and label it x. Usually the question, well, it's a question, so it's going to end with a question mark. Usually it's clear from the question what your unknown is, because it's going to go, oh, what is the weight of this? So your unknown, your x, is going to be the weight of the thing. So it should be pretty obvious what the unknown quantity is going to be. Just look for where the question mark is. After you've decided the unknown, formulate the equation. Use your understanding of maths, geometry, finding the area, the space of things. Use that knowledge to form an equation involving the unknown and the things that you do know in the question. Then solve the equation using the techniques that we've shown previously for solving quadratic equations. Step 5, check that the solutions actually satisfy your equation. So you're going to often get multiple solutions because it's a quadratic. You need to make sure that your solutions are actually solving the equation in the first place, and also that they're realistic. And lastly, answer the question in sentence form. So don't just give the answer as numbers. You need to actually answer the question in a sentence because it was given in a sentence. So let's have a look at this particular example. In the flag below, the area of the red stripes is 700 centimeters squared. What is the width of the red stripes? So step 1 is to read the question and visualize. I've read it. It's visualized for me. Step 2 is to decide on the unknown quantity. Well, it's asking what is the width of the red stripes, so x is going to be width of stripes. Now we need to formulate the equation, because that is step 3. So we need to work out what we do know. Known area of red stripes. So we need to work out a way to link the known quantity 700 with the unknowns. So the way that we're going to do that is work out a way or an expression for the area of the red stripes, because we know the total area of the red stripes. So this is the area of the red stripes. There's 2 rectangles here. There's 2 rectangles, but it's not as simple as just finding sorry, I'm going to write x there, and these are equal. It's not just as simple as finding the area of this long rectangle, which is 50 centimeters, and this short one, because then if you were to add those together you would double up on that. So you need to find the area of the long one, the area of the short one, and then take away the area of this box in the middle, otherwise it'll be doubled up. So the first thing to realize is, because they're rectangles, this is going to be a square in the middle. Alright, so we're getting somewhere. So if we wrote it in words, area of long stripe plus area of short stripe, and then I've told you that we can't double up. You can't double up counting the middle square. You need to take that away. So we need a minus area of middle square this should be equal to total red area, which we do know. So this is, I'm just trying to talk you through my thinking for formulating this equation. So area of long stripe plus area of short stripe minus area of middle square is going to be equal to total red area, which we know is 700. So we're getting somewhere. We need to work out the area of the long stripe as an expression. The area of a rectangle is the length times by the width. We know the long stripe is 50 centimeters long times by the width, which is x. Area of the short stripe is going to be the length of it, which is 30 centimeters, times by the width of it, which is x. Area of the middle square, we need to avoid doubling up counting of that. So we need to take it away once. The area of the middle square is going to be x times by x. And that altogether should equal the only thing that we know, which is that the area of the red stripes is 700 centimeters squared. So what do we have? 50x plus 30x, and x times by x is x squared is equal to 700. Simplify. 50x plus 30x is going to be 80x. Take x squared is equal to 700. Alright, this is looking more like a quadratic. Let's rearrange this. So you've got negative x squared at the front and positive 80x. I haven't changed anything, I just rearranged those. It's equal to 700. I don't like dealing with negative numbers here, so let's remove that negative 1. Oh, it's not going to be plus 80x anymore, because it's going to be, I've removed the negative 1, it's going to be negative 80x is equal to 700. Opposite of timesing something by negative 1 is dividing by negative 1. So if I divide both sides by negative 1, you're going to end up with that. So that's my quadratic equation. I'm going to solve for x to work out the different possible widths that it could be. So what I could do here is, if I was freaking out during the test or didn't know any better, I could just jump straight to the quadratic formula. But here I can see that this is going to be a completing the square situation. So completing the square was making the left hand side into a perfect square by adding a number to both sides that is half the coefficient of x. Negative 80 on 2 is equal to negative 40 squared. Negative 40 squared is going to be 1600. So I need to add 1600 to both sides. That's going to be, to complete the square, negative 80x plus 1600 equals negative 700 plus 1600. So what do we have here? X squared, take 80x plus 1600 is equal to negative 700 plus 1600 is going to be positive 900. Alright, now we can factorize. Factorize the left hand side. Factorize. That's going to be what is something that I can times by itself to get 1600. 40 times by 40. Can I add those together to get negative 80? Plus 40 is not negative 80. But if I did negative 40 times by negative 40, negative 40 plus negative 40 will make negative 80. So I can use negative 40 as product sum, but because they're the same, it's also perfect squares. Factorization is equal to 900. I'm going to continue my working out up here. Draw a line up there. So x take 40 is going to be equal to, what's the opposite of squaring something? The square root, plus or minus the square root of 900. The square root of 900 is actually a nice whole number. It's going to be 30, plus or minus 30. What's the opposite of taking 40 from something? Adding 40. So x is going to be 40 plus or minus 30. So x is either, what's 40 plus 30? 70 centimeters, or 40 take 30, 10 centimeters. Now, it's going to be kind of obvious that it can't be 70 centimeters because the stripe cannot be wider than the flag. So the solution must be 10 centimeters. Therefore, just make sure that I'm answering the question. The width of the red stripes, yep. The width of the stripes must be 10 centimeters. So, hopefully that helps you out. That was a long-winded question, but that's an example of using quadratics in a real situation. Now hopefully that helps you out, and I'll see you in the next video.